On board ships, piston reciprocating air compressor is widely used. Piston reciprocating compressors work in a very similar manner as does an internal combustion engine, but basically in a reverse process. They have cylinders, pistons, crankshafts, valves and housing blocks. They can be single-acting or a double-acting piston reciprocating air compressors on board the ships, which either single-stage or two-stage. A piston reciprocating air compressor compresses air in a cylinder using a piston in a way. Reciprocating compressors are like automobile engines. The piston is directly driven through a wrist pin and connecting rod from a crankshaft. Depending on their size, piston reciprocating compressors may have one or more cylinders, multiple cylinders, may be arranged in line, opposed or in a V. In each cylinder, piston reciprocating compressors have both a suction valve and a discharge valve. These valves give the compressor its ability to deliver air against a pressure difference. They're usually located in the head of the cylinder and passages connected to the high or low pressure side of the system. Let's follow the compression process in a single-cylinder, single-acting, single-stage, piston reciprocating air compressor during one complete revolution of the crankshaft. Starting with the piston at the top of its stroke or at top dead center, the piston begins to move downward as the crankshaft rotates. Because both valves are closed, the downward moving piston reduces the pressure in the cylinder. As the pressure in the cylinder falls below the low signed pressure and the suction line, the pressure difference opens the suction valve, letting air from atmosphere via air filter to flow into the cylinder. The piston continues down and pulls in more air until the cylinder is filled with low-pressure air at the bottom of its stroke. Once past bottom dead center, the piston begins its upward stroke. The suction valve closes as the piston moves up. It reduces the volume of the space in the cylinder, increasing the pressure of the air. When the pressure in the cylinder exceeds the high signed pressure in the discharge line, the pressure difference pushes the discharge valve open, letting the compressed air flow out of the cylinder. This continues until the piston reaches the top of its stroke and most of the compressed air has been expelled into the discharge line through an aftercooler before storing into a receiver. When the piston begins its downward stroke, the discharge valve closes. The complete cycle then repeats during each revolution of the crankshaft. In the single piston, double-acting air compressor compresses the air on both the upstroke and the downstroke of the piston, doubling the capacity of a given cylinder size. It has two delivery strokes for each revolution of the crankshaft. Instead of the connecting rod being attached directly to the piston, as seen inside a single-acting compressor, a crosshead is added between the compression piston and the connecting rod. The rod that connects the crosshead to the compression piston can be sealed to keep the cylinder completely encapsulated. The double-acting construction uses both sides of the piston, and compresses on both strokes during one revolution of the crankshaft. This gives a smoother air supply. In a single piston, double-acting, single-stage air compressor, when the piston moves upwards, the upper part of the piston compresses the air in the cylinder. The inlet valve closes when the pressure reaches atmospheric pressure. Further compression follows as the piston moves towards the top of its stroke. This is compression stroke. At the end of this stroke, the discharge or delivery valve opens, and the compressed air is passed through aftercooler, before delivered to a receiver. At the same moment, the lower part of the piston falls below atmospheric pressure, and the suction valve or inlet valve opens. The air is drawn into the cylinder, through an air filter element. This operation is known as suction stroke. When piston starts moving downwards, the pressure inside the upper part of the piston, falls below atmospheric pressure and the suction valve or inlet valve opens. The air is drawn into the cylinder through an air filter element. This operation is known as suction stroke. At the same moment, the lower part of the piston, the air is compressed. This operation is known as compression stroke. At the end of this stroke, the discharge or delivery valve opens, and the compressed air is passed through aftercooler, before delivered to a receiver. Multi-stage air compressors. Multi-stage air compressors feature a series of cylinders, each of a different diameter. Between each compression stage, the air passes through an intercooler, where it is cooled. Cooling the air reduces the amount of work necessary to compress it further. In a two-stage air compressor, air is then forced into an additional chamber where it is pressurized to the required extent. Benefits of multi-stage compression. 1. Improved efficiency. Two-stage air compressors perform less work to compress air to a given pressure, which means your operating costs are lower. 2. Better reliability. The intercooling stage of two-stage compression creates less chance of overheating, which in turn means more uptime and better productivity. 3. Less moisture buildup. Cooler air has a lower moisture content. Moisture in compressed air can lead to equipment failure and premature wear. Using a 2- or 3-stage air compressor can potentially save you from having to purchase a separate air dryer. 4. Smaller footprint. For heavy-duty applications, multi-stage air compressors deliver greater air pressure at higher capacities than single-stage machines of a comparable size. 5. Few maintenance requirements. Thanks to smaller components and cooler temperatures, wearable components don't wear out as quickly. As a result, recommended service intervals are longer. In a single-piston, single-acting, two-stage air compressor, the low-pressure and high-pressure pistons are connected in tandem to a single piston. In low-pressure stage, when the piston moves down, the atmospheric air is inducted. The compressor air from the first stage flows to the second stage through the intercooler. Pressurized air is inducted into the second stage. As the piston moves up, compression takes place in both stages. The high-pressure air from the second stage is delivered through the aftercooler. In the two-piston arrangement, single-acting, two-stage air compressor, the low-pressure and high-pressure pistons were connected to two separate cylinders. As a low-pressure piston moves down, air was inducted through the air filter from the atmosphere. Then it moves up, the air is compressed and delivered to the second stage through the intercooler. The air is further compressed in the second stage, the high-pressure air is delivered through the aftercooler to a receiver. In a single-piston, double-acting, two-stage air compressor, the compression takes place during the upward as well as the downward stroke of the piston. In this arrangement, the low-pressure, first-stage piston is at the top and the high-pressure, second-stage piston is at the bottom. In the first stage, as the piston moves up, air is compressed and the compressed air is inducted into the second stage through an intercooler. When the piston moves down, the pressurized air is further compressed in the second stage and delivered through the aftercooler to a receiver. In the meantime, the low-pressure stage inducts fresh air from atmosphere through an air filter. In this way, the process is cyclical. Air compressor valves. There are 3 types of valves. 1. Feather type. 2. Plate type. 3. Channel type. All 3 types of valves work in much the same way, even though their construction varies. The basic parts common to all 3 are about seat, 1 or more movable parts usually held in place by spring tension, and a guard or stop plate.